Hello and welcome to another weekly live stream. Looks like I can't get the music to play today. Oh, there it goes. So yes, welcome to another weekly live stream. We're going to be messing with AI architecture and stuff, trying to make some final decisions and whatnot. That's actually kind of loud, so I'm going to turn that off. Anyway, let's go ahead and get started. There's the superheroes scrolling up. We're back on the two machine system. I don't know why my chat here is not working. We will see if the other chat is working. Anyway, there's my patrons. Say hi. Let me see if the chat stuff is working. So we're back over on this computer. The two computer setup's a little weird, so testing. No, it is not. That is, oh no, I guess it is. It's just taking it a second. But the OBS chat is not working today. So that is going to be a problem, because that's normally where I read the chats, is on the OBS chat. I actually can't see the one on the other thing. So why is this not working? Let me try reinitializing it. Okay. See, docs. There's always got to be something, it feels like. Chat. There we go. Testing from OBS. Yay. Now, I don't know why I'm not getting sound. Maybe I'm using the wrong app. Nope, it's just taking its time. Okay, we got sound. Yay! Everything's working. I don't know if we have viewers, but Google says we have one. Or YouTube says we have one. Same difference. Alright, so I've been playing with AI architectures. So Mythruna currently has kind of a hybrid finite state machine behavior tree thing going on. Just at a low level, just to get the I just see things flashing up over here on the just a little. Let me see if we can that's already connected. Yes, that's nice. Fine. And let's bring up, oh yeah, I don't have any of my LibreOffice documents up. Let's just, so hold on a second. I am unprepared. So I've been playing with goal-oriented action planning is the short story, the short version of a long story. I had played with it many years ago, but there were some limitations in like the simple implementations that I didn't like, and so in prep for trying to get a bunch of this stuff done this week, because I'm off until the 5th. So let's talk about, we'll leave that there in case I need it. So let's see. AI architecture. Architecture. There we go. So options, there's let's see. There is finite state machine. FSM. These are nice because they're really easy to see. You can draw them on the board. They're but the finite well, finite state means there's like a fixed number of states, and that's sort of the limitation too. You have to have planned out everything in advance. And so then there's also behavior trees, which are very popular in I call them BT. Very popular in video games. Essentially, it's kind of like a finite state machine, except for you re-enter it every time. I think that probably, mathematically speaking, you can always turn a finite state machine into a behavior tree and always turn a behavior tree into a finite state machine. and depending on you know, the type of rules you have, one of those will be more elegant than the other. But and then there's goal-oriented action planning, which is kind of like, in a sense, a dynamic state machine. But we'll talk about what I mean in a second. So let's say, I'm trying to think of my example. So my example is, NPC wants to make a dagger, right? So naturally they're going to need some steps. You know, they've got to, you know, gather materials. So they've got to, you know, gather materials, heat the rod, whatever, take it to the anvil, bang on it, and so on. So you can build a state machine that says they have to do all these different things and can do them until done. You can, so a state machine might look like, yeah, I could have had like pre-prepared things, I guess, but so you might have, let's see. So you might have something that says, actually we probably just should stick in text mode for now. Oh gosh, how do I want to write this? So you'd have the state idle, and then you'd have the state heating tool. You'd have the state, you know, what do we, banging tool, you know, that kind of thing. And then, you know, you'd have, oops, lag is really interesting when you're trying to draw lines with a thing. So you decide so this means, you know, you decide you wanted to, you have the need to get a dagger, right? So you want to make one, and then so you heat the tool, hot enough, you know, hot, then you bang on it for a while. Maybe you have to do this when it gets cold. And then so, you know, then there's maybe a put it into storage kind of thing. And so if you just want to make a AI that looks like it's doing something, you know, you can have these predefined states, you know, and you know, so put it in storage, go back to idle. So you can have like these predefined states that it works through, but it's not very smart about what it does, and it can't be very dynamic. You know, like where did it get the materials to heat? You know, heat them. Where did it get the hammer, et cetera, et cetera. You end up building in all this stuff to make it more and more dynamic, and then you've got to like query the world, and the states just start to balloon. Meanwhile, you have like a behavior tree, which would sort of section this in a kind of a tree-like form, where you'd have like, see, how would this be done in a behavior tree? You would say, you'd have some kind of root that said, it's like so much easier to build them from the ground up. Yeah, so like a behavior tree has like sequences, and I think of them as ands and ors. But for this, like, just let me think. Might actually be easier to express it in the Word document where I have trees. So like a behavior tree might look like, because then I can just indent things further. So like you could set it up so that you have one node that's like a sequence of things, work the tool, which underneath it would say if tool cold, heat tool at forge, else if tool hot, bang on tool. So this would be like a loop, and then you get used to the hotkeys of one word processor, so you have like one and then put it away. And so these then could be nested further underneath like an idle behavior, if need tool, then you do all these things, that kind of thing. And so but you're constantly looping through. You start most behavior tree implementations are smart about this, but you kind of start at the root and you just keep executing behaviors until you find like the branch you want to go down, and so on and so forth. Even this is very, very static, right? I've already built all this stuff in, and we haven't even considered, again, where do we get the materials? Where do I get my hammer? Where do I find the anvil to bang on? Where do I heat the rod? Where do I find the forge, and so on and so forth. So there's the other thing, which is goal-oriented action planning. So in GOP you define some rules. You define rule or actions, essentially rules. In like an expert system, they'd be rules. Where you say, like, you have an action work tool, and that requires tool in hand, material, so material in hand, at forge, tool is hot, or not tool, but the material is hot. Let's call it a rod. I think that would be a rod in hand. So tool in right hand, rod. Let's do like this. Tool in right hand, rod in left hand. You're at the forge, and the material, the rod is hot, right? And so you build up rules like this that say, in order to work the tool, you need these things, and in order to heat the tool, requires. I should have done a tab here. Ooh boy. Yeah, the tab stops are set really big. Requires rod in a hand, any hand. It's say left hand. At anvil. Sorry. At forge. Rod is not hot. Oops. Right. And so you define actions, and you say, so there's the go to forge action, which requires nothing, essentially. Nothing. So anyway, so you have the actual action to work is to bang on tool, bang on rod with hammer. The work here is stick rod in forge, and like this requires nothing except for requires path to forge, basically. And so then the work is walk to forge. And so we have another action, which is go to anvil. Requires path to anvil. Work, walk to anvil. And so you can define these things like, what do we say? Get rod. Doesn't require anything. So the other thing is you talk about what it produces. So So this is what this produces is rod is hot, right? Yep. No, rod is, so rod is cold, or rod, so you created a dagger, created dagger, let's say. Again, I'm simplifying a bunch of things. So this would produce hot tool. Tool is hot, or rod is hot. This would produce at forge. This would produce at anvil. Whoops. Shoot. We're running out of space. So get rod requires path to rod. Let's just say it requires path to rod, or at. Say it requires that you be at the chest. And you can understand that if I had like a go to chest, it would look very much like these things, and we can talk about ways to make that better. So the work, get rod in left hand, oops, and then produce rod in left hand. Okay, and so on. You can see. You can see how you can build up these just simple rules where you can think about the atomic actions, like to work the tool, I need to have the tool, work the dagger, create dagger. Let's call this create dagger, hammer in right hand, rod in left hand. And so you can have rules on how to make these things happen. And there can be a variety of ways to make these happen. But the goal-oriented action planner says if my goal is that I want to create a dagger, then I start here at this action and I figure out what I require, and I try to find rules that will satisfy these requirements, based on what they produce. So if I need my rod is hot, maybe I'm already standing at my anvil, but that doesn't help me. Maybe I already have the rod in my left hand and the hammer in my right hand, but that doesn't help me because the rod is not hot. So then I need to look for actions that can satisfy that, and I go down until I find what, oh yeah, this one produces rod is hot. Maybe it produces some other things too, but this one produces rod is hot. So I'll add that to my plan. And so kind of you're slowly building up. You start from here and you're slowly building up, a sequence of events that, well, you explore all these different states to see which one might get you to your goal, because the way the rules link up together, and then finally you might find the path through here that gets you to your goal. In this case, we would have to potentially go to the chest, get the rod, go to the forge, and then once you're at the forge, heat the tool. When you're done, walk to the anvil and then bang on the anvil with the tool, so on and so forth. So from this, you kind of explore your options of rules. And, because even getting the rod, that could be a series of rules. Do I have it in my chest? Well, that requires at chest, rod in chest, right? And maybe you have another one that's, get rod that goes to your neighbor and asks, your neighbor if he has one, or you go to the town storeroom. And any of these things can be explored based on the conditions of the world or the conditions of your person, and so on and so forth. The classic example that you'll see is, I want to shoot the bad guy, or, the NPC wants to shoot the player, but his gun is empty, so he, back chains to figure out, what he has to do to, grab more bullets from his inventory, slap him in the gun, then he can shoot the player. It just gives the AI some autonomy. How I ended up here, though, is I'm really trying to think of the case where, now we're going to go back to sort of a map style, right? We've got in the town, maybe this is the home of the blacksmith. You've got maybe there's a a tavern where he goes to eat for dinner. Maybe his forge is over here where he goes to work. So let's see. Home. Tavern. Oops. And then shop, right? And so at any given time, when the player approaches the town, so let's say, this is the whole town out here. When you approach the town, I have an infinite world of infinite towns, right? So I need to decide, when you approach the town, what time of day is it? Where is everybody? And we may have lots of different buildings in here and lots of different people walking around and doing stuff. Oops. And so I need to decide, you've gotten here at 2 in the afternoon. What is the daily schedule of the blacksmith? Well, the daily schedule of the blacksmith says he's probably in his shop working on something. And so I needed to think about, that high level is not so hard to work out, but it does require a certain amount of, the town itself becomes an AI agent. Man, I just cannot keep this. I hope that I'm still making sound. You know what? I should change this so that I can see. Yeah. Okay. Cool. I couldn't see my microphone volume, so I couldn't tell whether I was still making sound. I keep kicking the cord with my foot. Anyway, so when you come here at 2 in the afternoon, I need to figure out that in a blacksmith's daily schedule that he's probably in his shop working on something. If it's in the afternoon, maybe he's at lunch, or in the evening, maybe he's at lunch, or at night he's at home, and so on and so forth. But I need to do this for all the NPCs, and I need to do it very quickly. So they all have like a daily schedule of jobs. But then once I get to their job, I need to know what exactly they're doing, what stage they are in that, what materials in the town, like say this is the storeroom over here. Like did he have to go there? And so anyway, so if I need to figure out the general case, but then you as a player, how can I change just the color? Aha. So you as a player have your view, which is only like at any given time, once you've entered the town, you can only directly see, when you're standing here, you can only directly see a little bit around you. And so beyond that, let's see. Let's use blue for the beyond that. And so then there's like one other level out where I need to keep track of the things that are happening. So out here, I don't care where the blacksmith is. I need to know what he's doing. Like at a rough level, I need to know, well, he's in his shop working on making daggers or whatever, right? Until he leaves that shop and enters this blue area, I don't need to know exactly where he is. I just kind of need to know the gist of where he is. So as soon as he decides I need to pathfind to the storeroom, I need to know that he becomes a different kind of AI. He's no longer passive. He's a low-level active AI. And so as soon as he enters this blue stuff, I don't need to animate him. I don't need to do complex pathfinding or probing or anything like that. I just need to have him walk a path. But as soon as he comes in this green area, I need to be ready to turn him into a real animated character. And I need to know exactly what he's doing and so on. And the reason this becomes important, because in order for the player to have agency in the world, I need to be able to have the player, let's say the player goes into the storeroom and steals all the rods. Then they need to expect that that's sort of holding up the blacksmith. He can't do his job. Even though they can't see him, maybe they leave and like move over to this corner of the town or whatever. maybe because they know that there's another place that the blacksmith will go and get rods and they want him to go over there or something like that. Anyway, you need to be able to have an effect on the town, even the town that you can't see in your immediate area, and have it all still work out the same as if you were roughly the same. The town and the larger world level AI can make some assumptions in general, but I want to be able to set it up so that you can cause actions in the town because they're smart enough to kind of work their way around. Or let's say you knew you needed to kill this guy and the best place to do it was in the storeroom, and so you go at night while he's at home, you go into his shop and you steal all the rods out of his chest, his local storage, so that when he goes in the morning and he has to start making daggers, he's got to go to the storeroom, and so you're hiding in the storeroom to ambush him and kill him because that's the best place for you to do it without getting caught, or something to that effect, right? So the town, while you're in the town, while you're near the town, needs to operate on this sort of things are really happening level. And so when I got that point in my design, I'm like, well, how do I decide what is really happening, and how do I make that dynamic enough? And so that's why I ended up with the goal-oriented action planning. And last time I did it, I didn't have very satisfying results. But I had kind of a design in my head when I started this on Wednesday or Thursday, poking around with some design notes, and then so over this past weekend I was able to implement something. And I've implemented as part of the MOS tool set. So so we've got a gope com.simsilica.gope package in the MOS libraries. So MOS libraries, for any of those who don't know, MOS equals Mythruna open source software. So that's the open source part of the things Mythruna is built on, like the MBlock library, the physics library. All these things are part of the open source stuff. And so I'm making a gope package that's in there, and I have like basic stuff written. And we can talk about the architecture of that. I don't want to go, so I do want to actually get work done today and not just talk about it. But here we see I have some test plans I've created. Like here I have a rule to move to B from B to C, which means if your location is B, then you can move to C. And see, that's the does, the action that you perform. And another rule, it moves C to D. So if you're at C, you can move to D, and if move B to D, which is like a shortcut. If you're at B, you can move to D also. And so then, and then another one to move from A to B. And so then if your goal is, like if you start at A, and your goal is to be at D, it should be able to automatically plan. In fact, I can simplify this code a little bit. It should be able to automatically plan a route based on the costs and so on and so forth, and figure out that it needs to, in this case, move to B and then move to D, because we're starting at A. And so it actually does. I could technically then encode maybe the rules we had up here in a way to kind of test that out with different scenarios. In fact, we could add some more get rod actions and then set up different preconditions to see if the NPC, I think that might be interesting, and it would be a decent test. So what I want to get to is like we have my different tools that we've used. The when we've done the AI, the animations, where we're trying to get everything to walk. I want to create a test tool like that kind of has it's kind of like this. I want to have not a full-fledged, graphic type of thing, but just like if I could do it in 2D, that would be fine, just to make the rules work, where I have something like this where it'll show like a scene where there's a bunch of buildings, different NPCs walking around, like the blacksmith, maybe there's a tavern keeper, different things, all with their own rule sets on, the kind of behaviors they should have and so on. and then have a little player icon that I can move around and visualize these zones, and some debug views on the side to show me what the town is doing as I move this debug view around, and make sure that wherever I put that debug view, I'm seeing what I'm supposed to be seeing. And then that will directly translate into something I can put in Mythruna. And so the goal is to have all of that done by the end of the year. So the next 2 weeks or week and a half coming, well, whatever, by January 4th, to have this at least working in basic form that can be tweaked and so on and so forth. So I'm trying to do the next level down, because as I've discovered, working at the low level we've been working at with the pathfinding, all of these things are useful. Like, I'll be able to plug these right into this system, the final system. But when I work down at those low levels, I sometimes am forced to make decisions that I don't really know if it's the right decision, because I don't know how the next level above it's supposed to be using it. And so I started the top down because, well, for one thing, if I finish this, all AI will be taken care of forever. It's just a matter of defining the rules and things and fixing bugs and so on and so forth. So this would be a huge step forward for characters in the game if I get this working. And so that's my focus over this next 2 weeks, because it's time to poop or get off the pot on some of this stuff, and as they say. And I've got the dedicated time, and that's what this kind of takes. So kind of like when I wrote the physics engine, it took 2 weeks of dedicated time, and this is going to take 2 weeks of dedicated time, and I happen to have the time set aside, so we'll see what we get done. Anyway, today I wanted to get kind of the basic setup of this done, but let's first do some. I just literally just got the planner and things working. Yeah, let's talk about the architecture. So there's action rules, and they have a so yeah, they have requirements, they have a name, they have requirements, they have the action, and then what it produces, the changes it makes to the world or the state, right? And you have a condition, which has kind of a key and an expression. You have action results, which is a key and a change that it makes. So like in this case, the key might be the location, and the expression might be where the key might literally be the word location, and then the expression might be where a particular place on the world, or at a particular entity, or so on and so forth. And conditions are more complicated than that, because it's more just a key. It's also a key that can get its initial state. So we'll talk about that in a second. So action results, a key and a change. Then you have a proposal, which is a goal or a particular rule, and the state of the world at that planning step. And so then you have a planner, and the planner takes a goal, iterates through the graph, produces a plan. And so typically you set up a bunch of rules, and those rules have conditions and action results. So these are conditions, these are action results, and these depends on the program. So this depends on the actual application. That is not something the library defines, it's just stuff. And so the planner internally will traverse the graph and try to find the things, and if we wanted to go through that, we can, but let's just play with it for a minute. And so let's make a now we know what a class. We want a complicated test. Let me make a separate It's a Groovy file. Okay, complicated planning test. Nope. I was hoping to. Okay, anyway, package. Let's just steal it from over here. All right. Okay, so let's test the simple case. Void test rod in chest. Okay. But we're going to set up our rules once, I think. In a Groovy test case, what is the before? Extends Groovy test case. Setup. Okay. All right. So we'll set up a new environment before every test, and we'll run different tests with different world states. And these are simplified world states, obviously. In the real one, we'd be, querying. Not a very talkative chat tonight, and that's fine. In the real version, we'd be querying the world for, items in the chest and stuff, where we're just going to assert certain truths. You'll see. So let me think. So let me kind of cut and paste this stuff over so we have something to look at. Okay. Let's just put this in here for now. Okay, so, and I'm still working out the API. This is all still very, very new. Like literally just, I got it working. I got my test written. Fortunately, it worked the first time, but I got my test written like only 2 hours before the live stream. So, and I still had to set up the live stream. So new action rule set. So we got the rule set, which could be shared among different NPCs. It's not necessarily specific. I think I'm going to add another layer which allows a particular plan to filter rules, because I think it would be really nice to have a set of rules that work kind of for all NPCs, and maybe delegate to rule or have a rule set specific to certain types of NPC, and that can delegate to the global rules, and then to have the rules themselves have some kind of condition on when they're activated. Like maybe a certain rule only works if you have an intelligence level above a certain amount, so that a dog wouldn't do it because a dog's not intelligent enough, unless that dog happens to be intelligent, and then it can do it. So depending on how you define your rules, and again, this is not Mythruna specific. I'm trying to make it general. So anyway, I'm getting off track. As it turns out, the Groovy for defining rules is really clumsy because it doesn't seem to let me chain these together and add them at the same time. So I'm wondering if I should create a helper method to do this a little easier. Anyway. And these names I give the rules, these are completely arbitrary. They're just to help identify it when debugging. So, create dagger. So I'm just going to give them names that are going to be distinct from the actions. So in this case, the conditions are, we want a bunch of conditions here. And in this case, we want a condition. And so you define these classes that are the actual keys of the condition. They're kind of like a key that can initialize the value. So I didn't call them key, I called them condition, a context value. I don't like this name, and I'm probably going to change it. I think context key works okay, and then it just can provide its initial value. from the world. But anyway, we have a we're going to find some specific ones here. So we're going to have a class holding, and it's going to implement context value. Oops. Just joined. Happy Sunday, all. Hey, Chuck Steed Moreland, how's it going? So in this case, we'll have like which hand it is. Whoops. That's what good for. Probably I could get away with just making it to string, but so then the world is where context value string, because it's just we're just kind of just messing around. String get world value, and in this case, world is going to be a map. So we'll say world got get left hand or hand. That's right. So that's like what we would get the world. Actually, let's call it hand dot holding. I'm trying to make it look like it might look sort of in the game. Yeah, so hand dot holding from the world. And what other kind of conditions we're going to need? We're going to need, so we got that covered. We're going to need a location condition just like we had before. So steal it from the other test. Again, I'm not doing real, we're just working on the logic, so we're going to assume that these classes can find their things, right? And so let's say container contents implements context value, and it takes a ID of the container, and string get ID return container contents ID, and object get world value def world. And so yeah, so this is going to be a, so again, we're going to make it look like it's children or something like that, right? We're going to make it look like it's a real code. So what else are we going to need? We're going to need class temperature. So similarly, this is going to be the temperature of an entity. Public temperature string ID. This ID equals ID. Public string get ID. Return. Yeah, actually, I'm going to add a parentheses here just for consistency. It doesn't have any parameters. It's always going to return the same thing. But this one is going to return temperature of ID. Actually, I can give these types too. So this is going to be a collection. This is going to be a double. Alright, and so then we got public object. In fact, so then these could be and so this location would be a string for now. Yeah, so string. Okay, I did that one. You know, really it would be something else, point or coordinate or something. So that's string still. Get world value is the one that now returns a collection. This returns a double. Get, and then this is going to be ID temperature. Let's call it. Oops, I forgot a quotation mark there. Okay, so I think we've got everything we need. So we've got conditions that were in the hand, at the anvil. We can make a hot and not hot. Yeah, handlers at forge. So I think we have all the types of condition we need to do all these. I'm going to move these up so that I can see them up here where the rules are. Okay, so where we're defining the rules up here, all right. So let's predefine some entities. So we're going to have string chest equals chest1, string inventory equals inventory1. Whoops. Hold on. I'm going to read the thing in a second. So save. Okay. Will there be Amazon or local hardware store to get the anvil? Ha ha ha. Yeah, well, I mean, maybe, right? If there's one in the storeroom and you've stolen his anvil and he has to go to the storeroom to get one. So, I mean, these are all ways we can build the rules and see how the NPC solves them. So I'm trying to make these look like entity IDs so that we, in fact, maybe I'll, no, I don't want to make this depend on the entity system just to, but I'm trying to make them look more like entity IDs. So let's actually, well, whatever. Okay, so we have an inventory. We have, so let's see. The condition for the, so we had holding, new holding left, and we want to say that is only true. Well, when we, the condition is when the holding is the hammer. Okay, so yeah, we need a hammer, and really, you know, you'd base it on types. Let's make a rod too. Right. So okay, so let's see. When we're holding in our left hand, and that's equal to hammer. Oops, no. And then we are at. Okay, and we have a rod in our left hand, in our right hand. No, this is right hand. This is left hand, and we have the rod in the left hand. I'm gonna make like for equals. It's so common. I'm gonna make a sort of utility constructor that makes that easier to do. But for now, I'm just spelling out all of the conditions. And so we need to have the hammer in the right hand. We need to be holding the rod in the left hand. We need to be at the anvil. So we'll just make those like, I'm gonna make, yeah, well, that's fine. And we need the temperature of the rod to be, I don't know what the right temperature is, so we'd say it dot is greater than just 200, right? Just has to be something. I think that works. And so then this is, bang on dagger. Oh, bang on rod with dagger. Bang on rod with hammer. And so then when we're done, the result is going to be that in our left hand, holding left dagger. Right. That's the goal, right? We want to be able to, when we're holding a dagger in our hand, well, let's say created dagger, just to be sure. Okay, so that's like the main rules. So now we need to have rules that can solve all the other things. Anyway, we just need to start breaking these down. Rule equals new action rule. We'll assume for a moment that so get rod from chest. Oh wait, it's not the convention I'm doing. Get rod from chest, and so that rule requires that we are at the chest. IT equals chest. Yeah, we've decided we're gonna just use strings for the locations. We're gonna assume that the only thing the containers can hold is rods for right now, but really this would be a different kind of query. New condition, new container contents of the chest dot size, let's make that so if it's null it'll be fine, is greater than 0. Right, so it has to have one in there in order for us to get it. And then if we, so what it does is it get rod from chest, and then the rule set changes new action results, new holding left, so we'll be holding, yeah, in fact I forgot the parenthesis here. We'll be holding the rod, what do we say, rod in our left hand. Let me see if this even compiles before we get too much further. So this is a unit test, so I'm basically running tests, and this is the complicated planning test. I just want to see if it blows up. It does blow up. So I've screwed up the syntax here somewhere. Oh yeah. Okay. The parentheses and the brackets look very similar to my eyes. I don't need the semicolon there. Invalid duplicate class definition. Oh, yeah, of course. but for sure for Mythruna, one of the things I'll do is build a like a sort of domain-specific language style set of utilities to make this a little easier to write rules. No signature method action rule set is applicable. Blink is applicable for arguments of blink. That's on line 89. com.simsilica.gope action. Oh, forgot the new. Typing and talking, that's what happens. Okay, so yeah, it's running. Okay, cool. So let's finish defining the rules. So the next rule we need, we've done this rule. And we'll, for our tests, we'll just always make sure that there's a hammer. Although if we don't have a hammer in our hand and we can't get one, yeah, so let's do this too. So let's get rod. Let's make a simpler rule, right? If we already have it in our inventory, get rod from form inventory. Then that rule requires no location. It only requires that we have it in our inventory. So again, the only thing we can hold right now are rods. So this is for us, our own container. Self. By default, all entity, basically, the way I'm going to set it up is that by default, when you're planning it, any entity you don't specify is going to be yourself. But for now, we'll say container contents. Oh, I already did that. For self, and if the size is greater than 0, then we can do it. Okay. Okay. Now, so I'm going to make some real quick notes for myself down here for a second. What if we have a rule to get to create a rod? Okay. Just things I want to think about. So then we have another rule. Yeah, that's fine. The 2 rules is good. And so now we need, like, how do we get to the different places we need to go? How do we heat the thing? So, because we need a temperature greater than 200. So, new rule, new action rule, heat rod. Rule requires it requires that we be holding the rod. We'll say for left hand for now. It doesn't really matter. And then location needs to be the forge. And I think we'll let the temperature stay out. So location needs to be the forge. Okay, so that's that rule. Oh, I'm not adding any of these rules. I'm forgetting to add the rules. I'm forgetting to finish populating them. What was that bubbling? All right, rule does get rod from inventory So in real life, this would be some set of like real actions that actually make the NPC go and do the things. I'm just using strings right now. Yeah, so we can steal this and make this the... It'll be holding the rod. Okie dokie. Get rod from inventory. And then we also want to say that we've changed the amount of items in our yeah, let's right, because we'll no longer have the item in there. New container contents self, and then the thing we're going to want to change is we're going to want to say self dot remove rod, and then we'll return self. This is a little weird because what comes in is the container, and so it's like an actual closure here. So we'll say from the container, remove the rod, return container. That's actually going to be a problem. So now we want to make we want to duplicate that. We want to, yeah. So we want to say container equals container clone, container dot remove, because as we traverse through the graph of things, each of these will have its own state of what the world was at this time, and so in order to not bleed state, we've got to make sure every one of these changes is making it to a new immutable object, so that some other rule that's running will still see it in the inventory as it's planning out and figuring out which rules could go. So we have to do that because we're actually mutating in an existing value rather. So now we're actually putting a new value in its place. It's a collection without that particular rod in it. And so we need to do a similar thing for, actually we can just say get rod from chest is the same thing, because the except for this is going to be container chest instead of container self, right? So right, we had it before, we removed it from there, and now it's not there anymore. So the heat rod, that's fine, and then the rule does hold rod in forge, and rule changes new. I think there's only one thing we change here. New action result. Oh wait, this should be an action result too. Yeah, I forgot that part. This is why I really want a DSL to make this a lot easier. So then the action result makes a new temperature of the rod, and see here we could be that we have to superheat it. So we could say that that the temperatures, we only raise, let's say the temperature, if you hold the rod in the forge for a particular amount of time, so let's say for 10 minutes, or for 1 minute, then that will only increase the temperature, plus, that's only like 100 degrees, right? So we should be able to see it like do this action multiple times, I think. Let me think about that. No, it won't work because it won't work that way because our condition is we don't have a condition here. We would have to have a condition here that says now how would we want to do that? Because there's nothing that's going to invoke this rule, because this result does not directly match any condition. Only gets us closer. Yeah, we can't do close with the current setup, so we'll just do it like that. We'll just make it. I try to make it too complicated, right? Okay, so we've got to heat the rod. I'm gonna move these down to the bottom because I'm running out of room. Alright, so now we need to be able to go to all the different places. And this would be really nice to have a template for. Action rule, go to where all the different places we need. Anvil. And so then that rule requires nothing. We just leave that blank. And rule does walk to anvil. Rule changes, new action result, new location. We're at anvil. One more. And then rule set. I don't know if it'll actually let me do this with a without any requirements, but we'll see. So we'll make a bunch of these. We'll make one for go to forge. Forge. Did we have one for chest? Yep. Go to chest. Okay, so let's see if we still compile. We're not going to do anything with it, but we're just, it's not running anything, just setting up the rules. Alright, so now we've got all of these. Right, I already did a get rod. Yeah, I did various get rods. Okay, so now we can start building a plan. You see, we need, yeah, so make some so we'll set it up. So this one will yeah, we won't start anywhere, but we do want to start holding, let's see, holding, let's say the right hand holding is the hammer. We're not going to be holding anything else. I don't think we need to be at any location. We do probably need to put we probably do need to put some containers in there. So let's say we had, what containers we have? Self, chest, and inventory. Oh wait, I didn't do inventory right. Get from inventory. Yeah, I actually already had resolved inventory. I didn't need self. Let me just see where all I'm using self. I didn't really need self. Yeah, okay, so we'll get rid of self. Alright, so we're gonna set inventory dot children. We're gonna make this an empty list right now. No, that's where we'll put the rod. We'll do the initial one where we can get the rod from the inventory. Find rod in inventory. Okay. And so we create our root context, which is sort of how we, at the root level, where we can like access the world, and then there'll be child contexts that like are local to anyway, planning step. And so then we say that so we create a planner, we give it the rule set, we give it that root context, and we say the condition is that we want to be holding the created dagger. So this is what we want our final condition to be. Oops. We could have more than one condition here, but this is the condition we want. Alright, and so then we shall see what the plan was. Found in boink. So we found it in however many, and then what we want to do is we want to planner dot plan dot each Alright, let's see what happens. Kaboom. Is it gonna blow up? Yep. Okay. No such property inventory 1. Oh, something's trying to interpret that as a string on line 71. Did I do something wrong here? Inventory 1. Oh, yeah, it's just inventory. Durr. Inventory 1's the string. Oops. Okay, so that was just a typo. No such property rule set. Okay, that's something more. I'm just gonna put this. This is sample entities for our rules, and then the rule set on line 135. No. Oh, I moved things around. Rule set. Oh. Yeah. Normal programming issues, not GOP issues. Alright, what now? String cannot be cast to Boolean on line 142. Well, that's just running the plan. So, looking at that, string cannot be cast to Boolean. That is in condition evaluate, so we need to add some debugging to condition line 70. let's just see what's going on. Start debugging the problems. So the val is null. We're trying to see if we're holding the closure. Okay, so I think it's my rule. It's messed up. I think I had like all these that were just it equals. You just double check all my conditions that are actually predicates. It equals chest. Rod. No, that's totally right. It equals rod. It equals forge. Okay. I'm going to real quickly add some strings to some of these. Yeah, see, this could have just been. Alright, so we get a little more debug. I can figure out which holding it's having problems with. Alright, so it is trying to run holding left. The value is null, that's totally fine. But why string? And that's in condition line 71. Predicate test. So one of these. How though? How though? Let me just do this. I think it's blowing up in here, but this way we'll be able to see. Just double check that that's where it's blowing up. I'm not getting a very good stack trace here. Yeah, so it's definitely blowing up in there. When calling predicate test, and the predicate is just a closure. This has got to be a groovyism, though. Uh-oh, the Pepsi's done. I've got like 4 bottles of water here, though. Oh, we're already at 9:20. Wow. I hope I've been entertaining. You guys have been awfully quiet. I really want to see this work. So let's... well, we know which rule is failing. It is... we don't exactly know. See, we're looking at the goal, and we're trying to evaluate holding left with this predicate. So it's this one. So we can actually put some debugging in here too. Let's try this. Maybe I have to have a return there. Oh, were we not even executing that? Or is it this that's messing up? No, it was definitely a condition. And we're not even getting this holding left, and so it's calling condition evaluate from is satisfied. Condition evaluate line 71, which is this. And context get value is returning a null and should return a null no matter how many times we execute it. Just making sure that the second call is also null. Yep, okay. So no matter how many times we execute it, we're going to get null each time, although this is different. Yes, okay, so right, but we still get null. Okay, so it's showing that it cached the value. That's good. But then we call predicate test, and that's where it blows up. But that's not what we're seeing in the stack trace. And in fact, sometimes the unit tests will lie to you about the tests index. There we go. Nope, it's not lying to us this time. But sometimes it lies to you about the actual line number because it does an abbreviated stack trace here. But we're doing it in a proxy test. So we've created... We never got the output from that. So somebody is coercing... Alright, let me do this then. Java util function predicate test predicate equals new. I just want to make sure we're using the exact one we want. Public boolean test object O. Print line testing the thing. Return O equals let's just return true for a moment. Let's comment this out for a second. And just put in our predicate here, test predicate. See what happens. Could not find matching constructor for action results. Holding predicate. Oh, I'm changing the wrong damn thing. Ah, frick. Oh well. At least I commented out the old code. I need to put this up here. Then we need to comment out this code. I have drank too much Pepsi today because now like my mouth all tastes funny. Test predicate. And usually I eat a piece of gum, but I'm not going to subject you guys to my chewing. Alright, so string cannot be cast to Boolean. Why though? Who is trying to cast a string to Boolean? That's the thing I want to know. Let's print line, test the thing, test predicate, test foo. Okay, so that, ooh. Oh, forgot to put the plus here. Test the thing, foo, test the thing, true. Okay. Testing the thing. Foo. So the predicate itself is working. And the predicate we have is still a closure. But it's not supposed to be a closure anymore. This is frustrating because this has nothing to do with what we're supposed to be working on and everything to do with just the wiring of Java to Groovy. I'm 99.99% sure. The predicate works on its own, passed in a string, passed in whatever. Let's just make sure that's really what's happening. Maybe we're running something else and I don't realize it. Let's comment out all of the other rules for a second, isolate it to just this one, just to be sure. I'm making a lot of assumptions. I mean, I have a pretty good idea because of the debugging output. Yeah, so we're 100%. We're failing right there, and there's no logic to it. Condition. This is I mean, I can even specifically type all this stuff potentially. Predicate string just to be sure. Thing is, like, it's I feel like it's not even running this particular code. The test predicate is planning test blah blah blah, you know, $1. But when we actually go to execute the condition, it's something else entirely. Which makes no sense to me. I may have to do something screwy here. That's interesting. One line is working different than the other. Like, this test condition does not look the same as this one. Like, let me show you what I mean. Okay, so we've got the condition we created directly, and then there's the one that's embedded in the proposal, which is requirements condition left. Yeah, see, this should be the same, but it's not. I think I am looking in the wrong place. I think I have proven that I am looking in the wrong place and that it's this that's actually the issue. Yep, look at that. That was the one that was the problem all along. It had nothing to do with this up here. Great. So now I get to put it all back the way it was. Yeah, so it had nothing to do with any of this stuff. That's awesome. Glad I wasted all that time with it. So we can get rid of all this stuff. Get rid of this. We're back to that. In fact, I can get rid of this as well. Alright, let's see what happens now. We'll fail and then blow up in a completely different place, and I'll regret having removed all that. Hey! That's exactly okay. So we're trying to plan, but one of the things we tried was going to the chest. I don't know why. Or we were looking at going to the chest, and so we needed to try the condition. But our rule for getting the things, what we want to do. Hey, how's it going? Welcome to the chat. So basically, if this is null, we probably just want to return an empty set. Oops, I was on the wrong account. Haha. It's sometimes tough to manage the multiple accounts, eh? Hey! Yeah, so we didn't find the path, but we searched them all. So now we have to figure out why it didn't find what we wanted to find. We tried some things. Yeah, so I can take out some of this other debugging too. It's going to be in our way. So for whatever reason, the rule set can't resolve. Maybe I did that on purpose. Did I leave out some critical? No. Okay. So we definitely are holding the hammer. I want to see in that first step we only branched once. Yeah, because we need... No, that's fine. So then we're looking at the proposal for create dagger. And then we branch. All the different things we would need to branch on. I'm going to add a thing so we can more easily see when we're in a new context. So like each of these is showing us a particular rule we're looking at, like a proposal. And so here, like the proposal is we're going to try to do our actual goal, which is to build the dagger. And so then we're going to look at the create dagger, because that's the only thing that would satisfy it. And the requirements for that are these. And so we go through these different branches where we can either get it from the inventory, we can get it from our chest. And we also need to go to the anvil, by the way. And so then we tried to get it from inventory, and we failed to do so. Because... do we have the rule defined wrong? Get rod from inventory. We don't need this anymore. We've ensured that there are always at least an empty set. Oh, there is no rod in the inventory. Actually, this is accurate, right? Because we missed a critical thing. We haven't... oh no, we did give it some children. Never mind. I'm wrong. We did put things in the inventory, and so now we need to debug a little bit. This. So if we get rod from the inventory, let's see, we want to say print line inventory size. Let's see. Inventory size 10. Oh no, how'd that happen? Get rod from inventory. How did the inventory size to get to be 10? Oh, that's the that's the actual string inventory. Inventory 1. Because, yeah, anyway. This is the container here, so if I wanted to be a little bit, you know, more expressive. Okay, so the inventory size is 1, which is definitely greater than 0. So we've already satisfied that. But then why are we branching to go to the anvil? That is not even a requirement here. Here's what I'm looking at. This particular thing, let me clean it up a little bit here. So we're looking at this particular action rule, which is to get the rod from the inventory. The requirements are that so we've got the requirements that the container has the thing in it. And that's it. Those are our only requirements. And so why? So the question then is, why did this basically wasn't satisfied? Or maybe it was. We're not logging the pops. So as it resolves things, it'll pop back out. So that's probably what it is. It is probably popping out. So there we go. All right. Okay, so back to the top. All right. We do that. We branch. Now we're looking at the get rod from inventory. We do that. We pop. Okay, so this is satisfied. And now we're trying to satisfy all these things. And then we need to go to the anvil. And so then we look at the proposal to go to the anvil, and for some reason we can't. Oh, it has no requirements. Oh, we pop. So we go back. And so from there we branch to get rod from inventory. We already have get rod from inventory. Okay, so something happened with our context state. We didn't. No, right there. We've got holding right hammer 1. Branch. Okay, so I recognize this is not easy to read. I wish I had a better debug view for you. But what this is telling me is that we went to look at go to anvil, we found we could, and so we popped back to the root where we're basically trying to create the dagger. Our plan is missing the something. Okay, let me rethink this. Actually, this is the tricky part of all this stuff, right? So in our hand, we are holding the hammer. In our left hand, we are holding a null. Oh. So the setter, the thing that was supposed to get rod from inventory, changes. Oh, we never. Yeah, so holding left. No, we should have been setting it. to the rod. And rod is set to rod 1. So something didn't apply those changes. I think I'm going to need to make a cleaner debug view. So for now, let's do get name. Dot. Next is fine because it might be null. And if it's not null, then we can pop get next, get action rule, get name. I'm just trying to clean up the output a little bit. Dot get name. Okay, so let's just see if that cleaned up the output. Yeah, okay. Oh, it's much cleaner, right? So first, yeah, so it needs to get dagger. So now we can add things like when we're checking for completion, we can is satisfies condition is satisfied. So we want proposal is satisfied. System out print line missing condition. Okay, so that should tell us why we're not satisfied at any given level. Okay. Looking at, so now we're missing holding left. So, yep. So that's fine because then we get the rod in inventory. We're missing location. No. Oh yeah, pop create dagger. So now we're missing the location. And so we're going to go to the anvil. And so we propose go to the anvil. We're missing holding left. But no, we set holding. So now we need to keep track of what we're setting. And so when we apply, so we're going to apply the change. I think I'm applying it to the wrong context, maybe. What we want to show is at each of these planning stages, we want to show what the current context is. Current context. So like what variables are active at that particular moment. Alright, so yeah, so what's this after we go to the anvil, then we pop back to create dagger. We're still missing holding left, but we should have applied when we popped get rod from inventory. We're applying the wrong things. So when we pop, we're applying the wrong things. We want to apply these. That's fine. Get rod from inventory. Pop. We apply holding left. Pop. We apply create dagger. Current context, holding right and holding left. Okay, so it's just our condition is failing. Our condition is running and it's failing. No, wait. That says we're still missing the location. I'm looking at the wrong thing, right? Okay, so first we try to create the dagger. Then we get the rod from the inventory. We don't apply it yet, but we go back up. And then we, looking at the proposal, go to anvil. We can totally go to the anvil, so we do. And we pop back up to creating the dagger, but now we're missing holding left, even though, and holding left is null now. So yeah, we messed up a nested context somewhere, because right here we still had it, and this should have been the same one. So it could be. Okay, yeah, so it's a context nesting issue. That's going to be tricky to track. So this is the let me add some more debugging here to the planner. So before we popped system out, we had nope. There's where we're setting that. Alright. So let's just see who's got the wrong context. Son of a beach. Isn't debugging fun? And we've got something else going wrong. Proposal, get planning context. Always a good time. Oh, it passed this time. Oh no, it always passes because it runs out of tries. I only give it 10 tries. Okay, so we go to the pre-pop context has everything. Oh, so we're already null again. We got rod from inventory. Oh, so here's the pre-pop context. We have still, it's wrong. Okay. Oh, we're already wrong back here. Get rod from inventory. No, that is fine. We need to actually get that up. So then, yeah. So now we're holding it. We still had it there. Then we get to here. We don't have it anymore. So this current context was somehow not the context we added back to pending. Oh. We already had a go to anvil in our... So this is the wrong go to anvil. because yeah, so we would have gone back to go to anvil with the pre-pop still. Oh, we have a temperature now. Something asked for the temperature. That's fine. I wonder if it's just I'm not giving it enough chance to work it out. Let me just try giving it more tries. If that's the issue, then there's a performance problem. But so let's try just giving it more tries. Yep, still found it in 10. But we don't print the plan. Well, we don't have a plan, though. That's not right. Is my planner messed up? Max. So why don't we have a result? So see, now it should be running a lot more. Let's make it 50 and print the result. Print line result, planner result. That's null. That's a problem. Or I mean, it could be that we tried all 10 branches. Yeah, so that's what it is. We basically had 10 branches to try, but one of these get rod from inventory. So see, what happens is we start at create dagger, but we need to satisfy all of these conditions. We need to be holding left the right thing. We need to be holding the right thing, and we need to be at the anvil. But we don't see that. Look, missing condition. Oh well, see, these are the things we can try, right? We can try get the rod from the inventory, we can try get the rod from chest, we can try go to anvil. And at this point, these are all length 1, so this is it's gonna try each of these until it can pop back up and be satisfied. And maybe that's the issue. No, so in this case, it will get the rod from the inventory and find out that yes, it can do that, and then it pops back up to this go to anvil, which just happens to be this one, where we didn't have any of the state necessary to do it, because we had, basically we hadn't gotten the rod from inventory yet. These are different branches of the paths, and so then later, right, because this parent was, I should print what the parent was. Well, I kind of do. This pop here does that. So somewhere we're looking for, we branched go to anvil from this get rod from inventory. So at some point we're going to see a go to anvil where its parent was get rod from inventory. So we need to look for go to anvil. Here's one, and its pop was still create dagger. That's not right. Oh yeah, sure it is. Because we erased our parentage because we've already satisfied it. But the plan should have included all of the things at that point. So we need to, in our debugging, include the plan. Pre-pop context, plan so far. Let's see if that sheds any light on it. I don't think we're adding the plan correctly either. Oh yeah, because this is not groovy. That's always the fun part of working in Java and Groovy at the same time. It's translating back and forth, switching modes in the brain. All right. So create dagger, we're good, no plan so far. Get rod from inventory. Plan so far is nothing, but the plan so far would be get rod from inventory once we go back to go to anvil. And for this one, the plan so far is nothing. Plan so far is walk to anvil. That's not helpful. Get so we need to look at another get anvil. The plan so far would be to get rod from inventory. Then we can apply our location, and then the plan so far would be to get rod from inventory and walk to anvil. And at this point, holding right and holding left should have real values. They do. Okay, so this is the right one, and the thing we're missing is nothing. Oh, we're missing the temperature. Okay. And so we need to... So we've added the rule, probably... Oh, we get no branching. So this is the issue. For whatever reason, we cannot solve this particular temperature rule, or temperature need. Nothing goes to heat up the... So that's where we've broken. And this is... I need to improve this debugging, because this is the kind of thing that if you're going to be defining rules... So nothing is there to heat up the anvil, or the thing that is heating it up is not... Oh. So when we try to heat up the anvil, or try to heat up the item on the anvil, we're only setting it to 200. But when we check, it has to be more than 200. So we're never heating it up enough until we say greater than or equal 200. So this is not a system problem. It's a rule problem. Check it out. Okay, so we walked through all those rules, complicated thing. It took us 35 traversals to find it, which is a performance problem I'm going to have to look into, because I don't think it should have taken that many. But so now we ended up with the plan. We get the rod from the inventory, we walk to the forge, we hold the rod in the forge, we walk to the anvil, we hold the rod, we bang on the rod with the hammer, and we make a dagger, basically. So it figured out the plan from all of that. It sorted through all the different paths and found the one that it wanted. Now there's some kind of issue with taking the optimal path or trying many things, but it's kind of like when we gave it all these conditions, it's got to try all of them, and so we end up with 4 branches right away to create this dagger. And it doesn't know at the time which one's going to be the shortest one. And so, you know, each of these that it tries to resolve is going to be another path through the tree. You know, so first it's going to try to find a temperature, but down this path it hasn't done any of the other things yet. And so it's got to try to do those. And one of these is going to be shorter than the other. And it did. It figured out the shortest one, which is get the rod from the inventory, walk to forge, just based on some rules that we created that were independent. And I think that's a good place to end it. We got it working, such as it is. I would have really liked to have seen the things walk around on the display so you could see what that means. But yes, we've got our plan. I'm going to actually put it a little big thing right here. Resulting plan, so that we can see the plan in action. And so we can make another test real quick. I'm not afraid to make another test real quick. So let's test where there isn't a rod in the chest. Right? There's a rod. Oh no, this was rod in inventory. So let's check when there isn't a rod in inventory, but there is a rod in the chest. right? And so now we should have an extra plan. And so we're going to do, what is it called? Test rod in chest. Test rod in chest. So there's no rod in the inventory. We're going to have to go to the chest to get it. We should end up with a longer plan, assuming we can solve it. Yep. Okay, so the resulting plan here is we've got to walk to the chest. We've got to get the rod from the chest. Then we walk to the forge. Then we hold the rod in the forge. Then we walk to the anvil. And then we bang on the rod with the hammer. So it created a better plan because it didn't have a rod in the inventory. It had to go to the chest. And that was all from independent rules. So this is basically what goal-oriented action planning will do for you. You define a whole bunch of rules like this, and it will traverse and find it. Kind of like pathfinding through the world. In fact, there's a vast number of similarities. So anyway, I'm happy with that. I can start visualizations tonight then, after I eat dinner. All right, everybody. Any last-minute comments or whatever? Otherwise, I'm going to hit the thanks page. Thank you for watching. If you please like, comment, subscribe. It really feeds the YouTube algorithm. I think you seem to pick up 1 new subscriber a week, which is kind of cool. But at that rate, I'll hit 1,000 subscribers in like a year and a half or something. Thanks a lot, guys. And I will see you next week. We'll probably do it on Saturday again, I think. So we'll see. I should have a lot more stuff to show by then. Anyway, I'll catch you guys later.